Baik, Assalamualaikum warahmatullahi wabarakatuh. Nama saya Hendra Wijaya, NPM G1C018012. Di, di sini saya akan menjelaskan apa sih meter rintangan atau multimeter. Nah, secara umum multimeter adalah alat ukur yang dipakai untuk mengukur tegangan listrik, arus listrik, dan tahanan. Sedangkan pada perkembangannya, multimeter masih bisa digunakan untuk berbagai fungsi seperti mengukur temperatur, induktansi, frekuensi, dan sebagainya. Ada juga orang yang menyebut multimeter dengan sebutan APO meter. Mungkin maksudnya A ampere, P volt, dan ohm. Fungsi multimeter sendiri adalah mengukur tegangan DC, AC, mengukur arus DC, mengukur nilai hambatan sebuah resistor, mengecek hubungan sikat atau koneksi, mengecek transistor, mengecek kapasitor, elektrolit, mengecek dioda LED dan dioda Zener, mengecek induktor, mengukur HFE transistor, dan mengukur suhu. Nah, sedangkan bagian-bagian penting pada multimeter adalah ada 3, yaitu display, saklar selektor, dan probe. Nah, selanjutnya untuk cara menggunakan multimeter sendiri ada berbagai macam cara, yaitu pertama untuk mengukur, misal untuk mengukur tegangan DC voltage. Pertama, kita atur posisi saklar selektor ke DCP. Kemudian pilih skala sesuai dengan perkiraan tegangan yang akan diukur. Jika ingin mengukur 6 volt, putar saklar selektor ke 12 volt. Jika tidak mengetahui tingginya tegangan yang diukur, maka disarankan untuk memilih skala tegangan yang lebih tinggi untuk menghindari terjadinya kerusakan pada multimeter. Kemudian hubungkan probe ke terminal tegangan yang akan diukur. Probe merah pada terminal positif dan probe hitam ke terminal negatif. Hati-hati agar jangan sampai terbalik. Untuk lebih jelasnya, mari kita simak video berikut ini dari sistem kerja dan cara menggunakan multimeter tersebut.
Circuits and components. Whether it's checking a battery, extension cord, or troubleshooting an appliance, multimeters can help determine exactly what has failed. If you've never used a digital multimeter, or if you're looking to refresh your knowledge, then this episode will get you started. First, we'll review how electricity works. Then we'll learn how to test for continuity. Finally, we'll do some safe voltage tests and talk about the limits of testing current. Let's begin. To understand what a multimeter can measure, let's quickly review some fundamentals. Electricity is the movement of electrons from one atom to another. The flow of electrons through a wire is somewhat similar to the flow of water inside a pipe. Voltage or potential difference is the pressure from the power source that pushes the electrons through the wires. Current or amperage is the flow of electrons within a circuit. Resistance, measured in ohms, is the amount that a material will resist the flow of electrons. Conductors have low resistance, allowing electrons to move easily through them. Insulators have an extremely high resistance to the flow of electrons. For example, copper wire is insulated by a plastic sheath. If we connect these wires together to a power source, we get a complete electrical circuit. Batteries provide direct current or DC power, as the current always flows in a single direction. This is represented by a dashed line on the multimeter. Your home is run off 120 volts alternating current or AC power. The direction that the current flows is changing 60 times a second or at 60 hertz. This is represented by the sine wave. In either case, the electrons always need a continuous path to return to the source. This is continuity, or a closed circuit. If we disrupt this path with rubber, plastic, or by air in the case of a broken wire, the electrons will not flow as there is no continuity. This is an open circuit. In many cases, the lack of continuity in a single component meter plug the meter leads into the terminals. Usually they are color-coded red for positive and black for neutral or common. Some meters will have two positive terminals. One terminal is for voltage and resistance, and the other is for measuring amperage. Always inspect the multimeter before use. Never use a multimeter that has a damaged case or test leads with nicked or damaged insulation. To be safe, always hold the multimeter from the insulated handles. Even 120 volts in your home can be deadly, so use caution before testing any live voltage. If you're unsure at any point, then it's best to contact a professional. Your model might look a little different, but all multimeters have the same common controls. Volts AC, volts DC, resistance in ohms, and resistance with tone, which will beep when there's continuity. As well, you can test for capacitance. Amps AC and amps DC. Some multimeters are auto-ranging and will automatically adjust the units displayed. In other models, you'll have to set the multimeter to the most accurate range. For example, if we test continuity at the 20K setting and we get a reading of 2.6, then the resistance is 2600 ohms. To test a component for continuity, first set the multimeter to the ohms or resistance with tone setting. Safely disconnect the power and remove the wires or connectors. Now remove the component or isolate it. Next, touch each probe to each component terminal. If there is no continuity, then the multimeter will display OL, or open loop. This means the component will need to be replaced. If there is continuity, you'll get a reading above 0 ohms, but the resistance will vary between load or non-load components. Non-load components, such as switches, thermostats, or fuses, provide an unrestricted path for the electricity to pass through. These will typically have a resistance reading between 0 and 1 ohms. Load components include heating elements, solenoids, motors, or any component that consumes power. They will need a specific resistance value to function correctly. For example, oven bake elements commonly have a resistance of 20 to 40 ohms, whereas hot surface igniters can range from 30 to 200 ohms. This is different for each component and will vary between models. If you want to learn more about the various components in appliances, then watch the video linked below. As well, continuity tests can be receptacles be replaced. If at any point a hot wire touches the metal casing, The ground wire provides a safe return path back to the source. If you connect to the hot side first, the other multimeter probe now becomes energized, which increases the risk of a shock.
Sekian penjelasan dan video dari saya. Apabila penjelasan dan kata saya kurang tepat, saya akhiri. Assalamualaikum warahmatullahi wabarakatuh.